Bismillahirrahmanirrahim. I am Professor Jameel and you are watching my YouTube channel. From today, we are going to start gamma function, which is important for various engineering disciplines, for BS students doing major in physics, mathematics, chemistry, etc. etc. Gamma function is denoted by the symbol capital gamma. Because of this symbol, the function has been named as gamma function, and there are at least 3 different definitions of gamma function in the literature for mathematical sciences or in the literature for physics and other disciplines. And we shall do all these 3 definitions one by one, but in this lecture I will start from definition number 1. So let's move on to the board and start the topic for gamma function. So gamma function, I am putting 3 lines over here, which means identical. These words would mean the same whatever is on the right hand side, and the symbol I am going to put on the right hand side is T, and just pull the right hand side a little down. This is the symbol for capital gamma, and this function, this is the symbol for gamma function, and the word gamma for the function is because of this symbol, and this is a function of some variable z. So whenever you come across this symbol gamma z, you would mean it's a gamma function. Let's start its first definition. Definition number 1. This is Euler's infinite limit. Euler's infinite limit. What is this Euler's infinite limit? Here you go. Look, what is this? 1 multiplied by 2 multiplied by 3 multiplied by dot dot dot. Dot dot means so on. So it's a product of 1, 2, 3 and so on up to n. So what is this? This is the product of first n positive integers. Product of first n positive integers. You understand that this product of first n positive integers may also be written as n factorial, but for the time being, leave it in this way. Why? You will come to know that gamma function includes the factorial as a special case, or in other words, you can say that gamma function would be a generalization of this factorial function. Let's check. Divided by z, this is a variable, z into z plus 1. How many factors have been multiplied? 2 factors. This is factor number 1, this is factor number 2. Multiplied with z plus 2. How many factors multiplied? 3 factors. And so on, z plus n. How many factors in total in the denominator now? First factor, this is second factor, this is third factor, and this is n plus 1 factor. Look again, this is the first factor, and z plus 1 is the second factor. This is the third factor. This whole is third factor and it includes 2. And this factor includes n, so it will be n plus 1 factor. So there is a total of n plus 1 number of factors in the denominator. And this whole thing is multiplied with n to the power z. This n is the same as used here in the factorial. So n to the power z. Now, whatever this is, it contains 1, 2, 3 and so on. Similarly, 1, 2, 3 and so on. All these are the constants. The general symbols in this expression are 2 in number. The first general symbol is n. For example, if n is 10, then it is 1, 2, 3, so on 10, and it is z into z plus 1, z plus 2, so on z plus 10, and into 10 to the power z. So there is n could be 11, n could be 1000 and so on and so forth. So n is a general symbol. Similarly, z is also a general symbol. It can have any value whatsoever. Right? So there are two general symbols which we call variables, and those variables are n and z. So whatever this is a function of two variables. Number one n, number two z. But if you apply this condition on n, that n approaches to infinity, then can you guess how many variables are in this expression now? This is a function of which variable? Is it a function of still two variables n and z, or is it a function of n, or is it a function of z? Let's check it with the help of an example. For example, if you have ax plus 4, for example, now this is a function of two variables. One variable is a and the other variable is x. But if you apply this limit, this condition on x, for example, then evaluate this limit. And evaluation of this limit means x will be replaced with 1. So let's replace a into 1 plus 4, and the answer is a plus 4. Look, this is a function of a and x, but the answer is a function of a only. There is no x. So whenever you evaluate a limit of a given function, then the variable for which the limit has been evaluated vanishes in the final answer. Right? Similarly, when you will apply this limit, then whatever you will get, that will be some function, and the symbol for that function is gamma, just as you write it as function of a and x. And for the symbol f, we have the symbol capital gamma, and n will not be here now. So what you will be left with? Only one variable, z. So it is a function of z. Right? So this, whatever is, when you will evaluate the limit, you will be left with only one variable, which is z, and it is a function of z. This definition of gamma function was developed by Euler. It is for this reason known as Euler's definition for the gamma function. Further, let me raise this example. What values of z will be possible from this definition? Look, if z is 0, which is a real number, this 0 multiplied with all these factors will produce 0 in the denominator, and 0 in the denominator mean whatever is above, mean in the numerator. 1, 2, 3, all these are finite numbers. Divided by 0 will make infinity. So z, where z cannot be 0. Similarly, if z is equal to -1, remember is again a real number. -1 plus 1 will make 0, and this 0 will make the whole denominator 0, and 0, here is a finite number. Look, n approaches to infinity, mean n is a finite number but very large. So when the finite number is divided by 0, that will also produce infinity. So we shall not use -1 so that this value remains finite. This function remains well defined. Similarly, if z is equal to -2, -2 plus 2 will make again 0, divided by 0 will produce infinity, and we do not use this value. And similarly, dot, dot, dot means so on, -n. Other than these values, whatever real number you use for z, this function is a finite function. Mean this expression will produce a finite value, whatever that value is. And if z is a complex number, it will also produce a finite complex number or a real number, whatever the case may be. So z is not 0, not -1, not -2, not -n. Other than these, the z can be a real number or a complex number. Look, is there a possibility that z can be a matrix? I mean, it can be a square matrix as used usually in physics. Then if z is a matrix, then this is a product of infinite number of matrices. Mean this is a product of very large number of matrices. And here you will have Z matrix and n will be a very large number. So large number exponentiated to a matrix. These mathematical objects are very difficult to handle and they have not been explored so far. It is for this reason that Z is for the time being not a matrix of any kind. So what are we left with for the possible values of Z? They are only real number and complex numbers, excluding these values. Means z cannot be 0, z cannot be -1, z cannot be -2 and so on -n. Other than these values, whatever value comes to your mind for z or for n, you can use that, right? But if you look in the definition, n is a positive integer. So when you apply this limit, remember in your mind that n is a positive integer because 1 multiplied by 2 multiplied by 3 and so on n. So n is an integer. You can also say check this integerness of n from here. That n is also, when n is 0 you have first value, when n is 1 you have this value, when n is 2 you have this value. So n, and let me write, and n is a positive integer. So in this definition, it is evident from the definition that in this symbol n ranges from 1, 2, 3 and so on n. So n is an integer. Okay. This is the definition of a gamma function, in which we have a function of z, but z will not have these values because the function is not defined for these values. Not defined means the function becomes infinite for these values of z. Other than these values, I am stressing again and again that these values, other than these values, this function is a finite function. Mean whatever value of z you will use, this will also always produce a finite answer in the form of gamma z. And this definition is named as Euler's infinite limit. Look, infinite limit doesn't mean that this value is infinite. Infinite limit means the positive integer part or piece in the definition approaches to infinity. Because of this infinity, it is infinite limit included in the name for gamma function due to Euler. So Euler's infinite limit, you can also say it Euler's infinite limit definition for the gamma function, and this definition is written in this form. Now, after completing this definition, let's apply this definition and evaluate various values of gamma function for various values of the independent variable z. And let's do this in the form of a question. Let me write a question for you. Question. And by the way, this question may appear in your exam, so be very careful in evaluation. I shall solve as many problems for the gamma functions as are possible, and for the most part of the time we shall be following the book by Afkan and Weber, whose title is Mathematical Methods for Physicists. We shall also be dealing and collecting questions from other books, and I will also be including some more questions from my side, from my own intuition. So let's start from the simple question. Evaluate gamma 1, mean find value of the gamma function when the variable z is equal to 1. Gamma 2, gamma 3, and generalize your answer to gamma m, where m is any positive integer. This is your question. First you will evaluate gamma 1, gamma 2, gamma 3. You may also be limited. Use Euler's definition in the form of infinite limit for the gamma function. Gamma of z. You have been restricted. I have told you there are at least 3 different definitions of gamma function. But in this question, you have been restricted to use infinite limit form of the definition of gamma function. So let's start the solution. First of all, we need to know what is the definition, which is Euler's definition in the form of infinite limit for gamma function. And this definition I have already given you in this form. So remember this definition, you need to use it again and again. So let me write this definition again for you. So let's start. The Euler's infinite limit for gamma function is. So I am going to write a definition for you. It is limit n approaches to infinity 1 into 2 into 3 dot into n over z into z plus 1 z plus 2 dot z plus n multiply whole with nz. This is the definition. Now you need to find gamma 1. So gamma 1 will be available to you when z is replaced or substituted with 1. So you can also name this equation as equation number 1 in your solution. Replace z by 1 to get gamma 1 as follows. So gamma 1 is equal to limit n approaches to infinity. There is no z in the numerator, so this part will be written again as such with no change. 1 2 3 dot dot n divided by, in the denominator you have z's everywhere, so replace wherever you find z with 1. So here you will get 1 into this 1 plus 1 will make 2, into this 1 plus 2 will make 3, into this z replaced with 1 will make 1 plus n, into n to the power z, that is 1. Okay, now have a look on this expression which you have got. There are factors up to n in the numerator, but there are factors up to n plus 1 in the denominator. But you know the meanings of these three dots. Mean many factors are hidden in it, and you can use those hidden factors. How can you use? You need to first recognize the pattern of the factors. Look, this is 1 and the next factor is 2, mean you have added 1. And the next factor is 3, means you have added 1 again, and so on. It is 1 plus n. Now if you move backward from this, you cannot find the pattern, so move back 3, and the previous factor is 2, so 1 has been reduced. This factor has been reduced by 1 again to get the previous factor. So this is n plus 1. What will be the factor behind it, mean on its left? It will be obtained by reducing 1 unit. So this is n plus 1. When reduced by 1 will make it n. So the factor here will be n. And this will make your denominator n 3 dots 3 2 1. N 3 dots 3 2 1. It's similar as in the denominator. So the many hidden factors in these 3 dots, you can reveal one factor because it is needed to make your denominator look similar to that part which is present in the numerator. So let's do this. Gamma 1 limit n approaches to infinity. Numerator is same as before, and what you have in the denominator, 1 into 2 into 3 dot 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 n into n plus 1 into n. This is same. It has not been simplified with anything else. Now if you look at these red curly brackets, then the denominator and numerator part are same, and these can be cancelled. This part, whole part, can be cancelled with this. So what are you left with? You are left with gamma 1 equal to limit n approaches to infinity, and in the upside part, meaning in the numerator, you have only n to the power 1, and in the denominator you have n plus 1. Now you need to evaluate this limit, and for evaluation of this limit you can take n out from this part in the denominator. Remember, there is a general rule of evaluation of the limit when the variable of the limit approaches to infinity. And what is the rule? Look for the highest power in any factor, either in the numerator or in the denominator. In the numerator we have only one factor and the highest power is n, so leave it as such. In the denominator there is only one factor and highest power of the variable of limit, mean n, is again 1. So this highest power, you should pull it out from the parentheses, or you can say round brackets, and let me do it. Let us do it. Let's do it. Let's do it here. So move in this part of the board. Gamma 1 is equal to limit n approaches to infinity n, and pull this n out. It can be written as then n into 1 plus 1 over n. N has been taken out of the bracket, so here is 1, here is no n. So whatever you pulled out, that should be brought in the downside for 1. This n will be cancelled because n is not infinity. You should understand the meanings of the infinity. This means n is a very, very large number. It is not equal to infinity. If it is infinity, then this infinity over infinity cannot be cancelled. So this is the idea of the limit, which you should be well acquainted with. And what are you left with? You have n approaches to infinity, 1 over 1 plus 1 over n, and now apply the limit. 1 over 1 plus 1 over infinity, and 1 over 1 plus 1 over infinity is 0, and the answer is 1. So gamma 1 is equal to 1. So make a box on it, because this was asked in the statement of the question. So this is your first answer, and you should remember this value as well, because you will need in higher problems and other problems which I will solve for you about gamma function. Now we need to find gamma 2, and for gamma 2 we shall use equation number 1, mean definition in the form of infinite limit in this definition, and will replace z, this z, by the number 2. So let's do this. For gamma 2, let us replace z by 2 in equation 1 or definition 1, whichever you like. So gamma 2 is equal to limit n approaches to infinity. Again, there is no z in the numerator, so keep this part same again. So rewrite it. 1 into 2 into 2 into 3 dot 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 n over. Now this z will be replaced by 2. So there is 2 into, here 2 plus 1 will make 3. Next 2 plus 2 will make 4 dot dot dot, and this will make 2 plus n, the last factor, 2 plus n into n to the power 2. Now simply you need to simplify this just as you did simplification here, and you use the meanings of these 3 dots. These 3 dots are again here, and these 3 dots means there are many hidden factors here, and you can reveal any number of factors according to the pattern. Look, how many factors now in the numerator? N factors. And how many factors in the denominator? There is no, this is 2 plus n. Let's count the factors again later on. First 2 plus n, and here is n. So you need n plus 1 and n. Look very carefully. As you move from right to left, each time the left factor is reduced by 1. So do this for 2 plus n. Limit n approaches to infinity, 1 into 2 into 3 dot 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 n over, there is no 1, you can multiply with 1 also, so that the denominator is possible to be made similar to the numerator. 1 into 2 into 3 into 4 dot 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 n into n plus 1 into n plus 2, and this is n to the power 2, same as in the upper step. Okay, 2 plus n, the previous factor is n plus 1 and the still previous factor is n. We have reached n. Why? Look, there is a product of n first positive integers and the similar object is in the denominator now within these brackets. For this purpose, we revealed the hidden factors in these three dots. Two factors have been revealed, n plus 1 and n. Now, this whole part in the denominator can be cancelled with this. And what are you left with? You are left with gamma 2 equal to limit n approaches to infinity. In the upside, this is cancelled, means here is now 1. 1 multiply n square will make n square, and the denominator will give you n plus 1 into n plus 2. Now you should evaluate this limit. And the rule for evaluation of this limit, I have told you here. Use that rule. There is only one factor in the numerator and keep it. Now, in this factor, the highest power of n is 1. Pull it out, mean n into. When this is pulled out, you will get 1 here plus 1. There is no n, it will be 1 over n now. Similarly, here is highest power of n is 1 and you should pull it out from this round bracket. So n into. So this has been pulled out. There will be 1 left here plus 2 divided by n. Now this n multiplied by n will make n square and this cancels here. Why it cancels? Give the reason again, because n is not infinity. This symbol means n is not infinity, but it's a very, very large number. Okay, so limit n approaches to infinity. In the upside you have 1 because it has been cancelled, and in the downside you have 1 plus 1 over n into 1 plus 2 by n. Now apply limit, and what does it mean? Replace everywhere n by infinity. So let's do this. Let's do this here. Gamma 2 is equal to 1 over 1 plus 1 over infinity into 1 plus 2 over infinity, and you will get gamma 2 equal to 1 over 1 plus 0 into 1 plus 0, and gamma 2 is again 1. So gamma 1 was equal to 1 and now gamma 2 is equal to 1. Make a box on it and write ANS, mean answer, because this is answer to your question. So whenever you have found the answer, please mark it with ANS, and you can name it with equation number 3. The gamma 1 was named as equation number 2. This is equation number 3 because you will use it for generalization purpose for gamma m as asked in the question. Now you need to evaluate gamma 3, and let's solve it. Solve the, I shall erase this both. And make a heading. What is your heading? For gamma 3, let us replace z by 3 in equation number 1, which is the definition. Here is, which is the definition. And here you need to replace. And you will get gamma 3 equal to limit n approaches to infinity. There was no z, so 1, 2, 3, so on, n is the same as before. And in the denominator, look, when you replace z by 3, then there is 3 into 4 into 5 and so on into 3 plus n. Let's write it. It's 3 into 4 into 5 dot 3 plus n and into n to the power 3. N to the power 3. Here is n to the power 3. So it is n to the power 3. Now, you need to make denominator same as numerator. And numerator contains factors up to n, but the denominator contains factors up to 3 plus n. So the previous factors will be 2 plus n, 1 plus n and n. Let's reveal those hidden factors here for the 3 dots. So limit n approaches to infinity, 1 into 2 into 3 dot n over 3 into 4 into 5 dot n into n plus 1 into n plus 2 into n plus 3 and dot n cube. So 3 plus n, the previous factor would be n plus 2, n plus 1 and n, right? Okay, but in the numerator the factors do not start from, in the numerator the factors start from 1, but in the denominator they are starting from 3. So there is a deficiency of 2 factors, mean 1 and 2. So you can multiply and divide by 2. Multiply and divide by 1 into 2. So limit n approaches to infinity, 1 into 2 into 3 into dot n over 1 into 2. Here we are first dividing 1 into 2 into 3 into 4 into 5 dot n into n plus 1, n plus 2, n plus 3. And you need to multiply with these 1 and 2. Let me change their color. 1 into 2, 1 into 2. So these have been multiplied and divided. Rest of the pieces are same, mean n cube is already here. Check the denominator up to n and the numerator whole. These are again same. And when these are same, so this whole piece can be cancelled with this whole red curly bracket in the denominator. So when this is cancelled, you will get 1 here. When you will cancel, you will get 1 here. And what is your result now? It is limit n approaches to infinity. So 1 into this blue, 1 into 2 into n cube, which is black. And in the denominator, you have n plus 1, n plus 2, n plus 3. This bracket is completed, n plus 3. And now you need to evaluate this bracket, mean this limit. And the rule is same again. There is only one factor in the numerator containing n, leave it. But there are three factors in the denominator. And each time you need to pull out highest power of n from the factor. So in the next step, limit n approaches to infinity, n cube, let me write 1 and 2 also. So 1 into 2, leave this 1 multiplied by anything will not affect anything. N cube over n power 1, this is pulled out and you will get 1 in place of this, and plus here you will get 1 over n into n is pulled out, you will get 1 plus 2 by n into n, this n highest power 1, this is pulled out, and you have 1 plus 3 by n. Okay, in the downside, n multiplied by n will make n cube, and this n cube, this blue n cube is cancelled with upside n cube, and you are left with 1 into 2 in the upside and these three factors in the downside. Let's write them separately. Here, gamma 3 is equal to limit n approaches to infinity, 1 into 2 divided by 1 plus 1 over n into 1 plus 2 over n into 1 plus 3 over n, and apply the limit now. This is gamma 3, little bold, 1 into 2 over 1 plus 1 over infinity, 1 plus 2 over infinity, 1 plus 3 over infinity, and you have 1 into 2 over 1 plus 0, 1 plus 0, 1 plus 0. So gamma 3 is equal to 1 into 2. This is your third answer as asked in your question, and you can also name it as equation number 3, and then it is equation number 4. You should look, 1 into 2, I have not simplified it to simple 2 because 1 multiplied by 2 is 2, but I haven't done this. I have written 1 into 2 again and again wherever it was required. Why I have done it? Because we need a generalization. So whenever you are asked to generalize from the trivial results or from the specific results as you have found gamma 3, gamma 2, gamma 1. So for the purpose of generalization, whatever original you get from your calculation, keep that result in its original form so that you can go to generalization. Now we have calculated gamma 1, that was 1, and gamma 2 was also 1, and gamma 3 is now 1 into 2. What will be gamma 4? The pattern is not so far visible. So for the purpose of generalization, we should calculate gamma 4 first. So let's calculate. So for gamma 4, look, for gamma 4, here, let us replace z by 4 in equation 1. So here you will get 4 from equation 1. Here is your equation 1. This is gamma 4. So upside will be same. And in the downside, your number will start from 4 because you are replacing z by 4. 4 into 5 into 6. and so on 4 plus n. 4 plus n. So 4, 5, 6 and up to 4 plus n. 4, 5 up to 4 plus n. And n to the power z, and z is 4, so 4 here. So what next? How many factors you need to make appear here so that you reach up to n? So these factors will be, look, I make a little change in my earlier calculation. This is n plus 4. N to the power 4. Look, n plus 4, 1 less n plus 3, 1 less n plus 2, 1 less n plus 1, and 1 less is n. You have reached n as required for the numerator. And now these factors start from 1, 2, 3, but these starts from 4, 5. This is 4, 5. What you need to multiply and divide to get same numbers here? There are missing 1, 2 and 3. So multiply and divide by 1, 2, dot 3. So when you will multiply and divide, you will get here, I write in blue as before, 1, 2, 3 and 4, 5 are same. Here you need the same step, n plus 3, n plus 4 and n to the power 4, right? And multiply with the blue digits, 1 into 2 into 3. This blue, 1, 2, 3, 1, 2, 3 has been multiplied and divided. This piece is same, and 4, 5, 6 in the black is same. Now look within the red brackets again. 1, 2, 3, 4, so on n. 1, 2, 3, so on n. These two will cancel, and you will be left with this 1, 2, 3 in the numerator. 1, 2, 3 in the numerator. Look, 1, 2, 3. This one is unnecessary. You should not write it. And multiplied with n4. And in the denominator, n plus 1, n plus 2, n plus 3, and this n plus 4. And in this, you have 1 into 2 into 3, same as before. This is n4. And this is up to n plus, n taken out, you will get this. N taken out, you will get this. N taken out, you will get this. And from this n taken out, you will get 1 plus 4 over n. Right? And this n multiplied by n and this n. This will make n4, and it will cancel from the upside. And now you are left with let me use this part again. So gamma 4 is equal to limit into upside has 1 into 2 into 3, and downside has 1 plus 1 over n, 1 plus 2 over n, 1 plus 3 over n, and the next is 1 plus 4 over n. And when you apply the limit, 1 into 2 into 3, This is 1 plus 1 over infinity, 1 plus 2 over infinity, 1 plus 3 over infinity, and 1 plus 4 over infinity. And your result is now 1 into 2 into 3 divided by 1 plus 0, 1, 2 over infinity is 0, into 1 plus 3 over infinity is 0, into 1 plus 4 over infinity is 0, and you have 1, 2, 3. This is gamma 4. And you can name it as, there was equation number 4, and now this is equation number 5. So gamma 4 is 1, 2, 3. Gamma 3, as you found, for purpose of generalization, let us write all the results which we have found together here. For generalization, to gamma m, let us collect our results from equations 2, 3, 4, and 5, and write as below. We collect all the results together in one line. So what is special with us now? Now gamma 1 is 1, gamma 2 is again 1. It was 1. Gamma 3 was 1 into 2. And this is gamma 4. Gamma 4 is 1, 2, 3. Now, can you guess the pattern? The pattern is visible from gamma 3. Gamma 3, it starts from 1, goes up to 2. 4 mean 1, 2, 3. And so on. Gamma 5, you can guess, will be 1 into 2 into 3 into 4. The last digit is 1 less than argument of the gamma function. In gamma 4 ends at gamma 3, gamma 5 ends at 4. And gamma 6, it will be 1 into 2 into 3 into 4 and into 5. And gamma m, this implies gamma m will be 1 into 2 into 3 into 4 into 5 dot, where it will end. The ending factor is 1 less than the argument of the gamma. So now this is 6, it ends at 5. So m will end at m minus 1. So this is m minus 1. So this is the general result for gamma m. These dots, these are the 3 dots. Now, you already know this 1 into 2 is 2 factorial, 1, 2, 3 is 3 factorial, 1, 2, 3, 4 is 4 factorial, and 1, 2, 3, 5 is 5 factorial. What it should be? It should be equal to m minus 1 factorial. So your gamma m is a product of first m minus 1 positive integers, or this product can be written in the form of a factorial. So gamma function is a factorial function when the argument z, which was gamma z, and z is now looking as m. So when argument of the gamma function is a positive integer, then gamma function is a factorial function. This is important. So factorial function is a special case of gamma function. And you have also found the generalization. This is your last answer according to your question statement. So gamma m is the product of first m minus 1 number of positive integers, mean it is m minus 1 factorial. So this finishes your question, and what we learn and what we should remember in this pattern of factorial. If it is 4 factorials, 3 factorial, 2 factorial, and this will be 1 factorial. And everybody knows that this one can also be written as 0 factorial, so that 0 factorial is 1 and it makes a pattern 1, and the factorial is 1 less. 1 minus 1 will make 0. If it is 1, this is gamma 2. So gamma 2 is 1, 1 less. Gamma 1 has a special value. So you should not use it here. The pattern is quite visible from here. And this is a very special value. So please remember it separately. So gamma 2 is 1. It's 1 factorial. Gamma 3 is 2 factorial. Gamma 4 is 3 factorial. And in the end, gamma m is m minus 1 factorial. Okay. So the question is finished. Let me write a note for you to remember the things. And in some separate lecture, I will explain to you the 0 factorial is really a 1. It might be the case that you have learned it without any reason. You have remembered it, in fact, that 0 factorial is always 1. Why the 0 factorial is always 1, I will explain to you in some my coming video lecture. For the time being, it is not necessary. Keep this gamma 1 as 1. And let me write a note for you to remember the things. Note mean you should remember these results. Number 1, value of gamma 1 is 1, and gamma m minus m is equal to m minus 1 factorial. And if we replace m by n plus m plus 1, then gamma m plus 1, replace this m by m plus 1. You can keep the symbol same or you can keep the symbol different. N minus m, you can write n minus n. Do the same here. M n plus 1, and this minus 1. It's just a replacement. So gamma n plus 1 is n factorial. You should remember these 3 boxes. Never forget these 3 results. Gamma 1 is equal to 1. Gamma m is m minus 1. Mean whatever is in the argument, the factorial of the digit is 1 less than this m. And this n plus 1 is n factorial. This is guess. For example, if you have gamma n plus 4, it will be what? N plus 3 factorial. You should also be able to use it. And if it is gamma n plus 16, for example, then it will be n plus 15 factorial. For the case of factorial, you need to reduce the argument by 1. And if it is gamma n plus m, it will be m plus n. It will be m plus n minus 1 factorial, etc., etc. I hope you have some confidence in your calculation skill, and I believe and I should hope that you will remember these results. In addition to the definition for the gamma function, which is Euler's definition for the gamma function. Please remember it as well. The problems on gamma function, they are very, in fact, remember, there is no other way of learning science except solving problems of science with your own pen and pencil. So keep watching my video lectures for more solved problems and the strategies how to solve the problem. I will not only solve the problem, but I will explain to you the strategy which is required and why that is the only strategy or some alternative you have. I will explain and uncover all these things to you for not only for the case of gamma function but for all the other articles of mathematics and physics as the case may be. Thanks for watching. Keep watching my channel for more solved problems with strategies. Please subscribe my channel as well so that every new video lecture comes to you in the first place. Thanks for watching.